Continuing on with the implementation of the priority queue. In this video, Lee will be implementing the peak method.
Right. Now, peak, as we mentioned before, is pretty much, interesting. So apparently I can't hit enter anymore.
Well, do you still have the program running? My guess is yes.
Hey, what are you doing? Hey, apparently I had the program still running.
Yeah.
So you can't change code too much while you're
Too much?
yeah. Well, you can a little bit, which is kind of weird. But yeah, you can modify code while you're still debugging. But back on track, what I was saying is we explained earlier, peak is pretty much the same as dequeue with the exception that we do not remove what we're returning from the queue. So its structure is going to be very similar. So we need to create an item to return, just like before. We're going to initialize it with the default of type T and return said item. Do a couple of checks, mostly to see that if we have anything in the list of the high priority list. So we're going to check if count is greater than 0. If it is, item equals high 0. Else if medium.count is greater than 0, then item equals medium, element 0, and then finally else if low.count is greater than 0, item equals low element 0. Build it, no errors. Let's go over here. And in this case, I don't want to do this because it would be an infinite loop. But what we can do is switch it up to be a loop. And then after we loop through everything, we'll just print out the count. So if we run it, interesting. All right, something exploded. Program that worked, 4 elements still left in the queue. So we're not getting an accurate count back.
Well, think about your logic with...
Oh, hold on. How about I call the method I'm trying to test? Just saying that might have something to do with it. Now, interesting thing. So we've got 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we still have 9 elements left in the queue. Now, what's going on is you may think this is wrong. It is not. This is what it's supposed to do. Peak shows you only what the very next element that is going to be dequeued is going to be. It doesn't iterate through the list. So it's always going to return the same thing. but it doesn't remove that item from that list. So even though we've peaked 9 times, we've looked at the next element to be removed, but we've never removed it. So our count is still going to be 9 by the end of it, which is exactly what we see.
Mm-hmm.
So that's what I wanted to demonstrate. But it does help. If you're trying to demonstrate peak, make sure you're using peak.
Gotcha.
So,
of course.
a little tidbit, that's one of those special tricks.
Okay. Well, with that, that's going to wrap up this video. In the next, we will take a look at the implementation for the contains method. Thanks a lot, everyone.